Hey everyone, welcome back! In previous videos I've showed attaching a flexible shaft from a rotary tool to my 3D printer. Whilst it has worked quite well, I did encounter some slight Z-axis movement at the end of the handpiece, which meant it wasn't suitable for precise Z-axis milling. So today I have a new handpiece to try. Made entirely of metal and quite heavy, will this handpiece provide the Z-axis precision that I'm after? Well, that's the plan. Let's find out. I purchased this handpiece and flexible shaft from Banggood. They were more expensive than my original setup, but still quite affordable. The handpiece is made entirely of metal, with what looks like an aluminium exterior. It's also quite heavy. Just to put that into perspective, I'll weigh this on my scales, just to give you an idea of how heavy this handpiece is. 160 grams. The handpiece uses a chuck clamping mechanism to grasp onto the shaft of the end mill you'll be using, which I much prefer over the other flexible shaft that I have, which uses different size collets to clamp onto the end mill. But what I find quite amusing here is it also comes with a chuck key, of course, but the chuck key is almost the same length of the handpiece itself. But as you can see, the chuck key is just on the end here. It's just embedded inside this plastic mould. The chuck accepts shank diameters up to 4mm, which allows way more choice when choosing an end mill. There seems to be far more options at the 4mm shank size than the 3.2mm we were limited to with previously. When you spin the chuck by hand, it spins very freely, doesn't bind. Also, it feels like it has a lot of weight inside that's also moving. But most of all, I can't sense any movement in the Z-axis. It feels rock solid, and of course in the X and Y axis I can't feel any movement there. But because it's so heavy, it'll be interesting to see if the rotary tool has enough power to spin this, especially when it's under load. To attach the handpiece to the flexible shaft has a keyed end on one side, and that keyed end slots into the top of the handpiece. You can just see in there, there's a slot for it to lock into. Line those up and push in the key, and it clicks in and it's held in place using this ball bearing attached with this metal spring. So that's now attached on the handpiece end. To detach this is quite easy. Just give it a good yank. So now when we spin the chuck, you'll also see on the other end of the flexible shaft, that spins as well. So to attach the other end of the flexible shaft to the rotary tool, you see there's a thread inside here which will neatly thread on the outside of the tool. That's good. But before we just screw it on, we do need to attach the end of the flexible shaft to the rotary tool. To do that, first of all, place the nut over the end of the flexible shaft, followed by the appropriate collet that comes with the rotary tool. Get that to focus, there we go. So that slides over like that. It's now ready to be inserted into the end of the rotary tool. Push down that locking pin, tighten the nut, making sure that the end of the flexible shaft is always butted up against that nut. Grab the little wrench that comes with your rotary tool while still holding in that locking pin and tighten it up. There we go. And lastly, push down the end of the flexible shaft housing and screw it onto the Dremel. That is now ready to go. I'll spin the end of this. You'll see it spinning inside the Dremel. When attaching the end of the flexible shaft to my 3D printer, on my original flex shaft here, I was attaching from about this location. So measuring this location is approximately 20 millimeters in diameter. About there. So to attach this particular flex shaft to the XY carriage, I had designed and printed up this mount, which allowed it to slot in, clamp down, around, and then also there's 4 fixings to clamp onto the X carriage on the 3D printer. Unfortunately, with this new handpiece, it is a larger diameter than the old one. It is approximately 25 or 25.5 millimeters in diameter. No problem, just quickly whipped up a larger version of this one with a slightly larger than 25 millimeter diameter. Slots on nice and tight, allows you to clamp down with these 4 screws over the top. And lastly, you can see the 4 fixing holes in the rear to clamp this onto the X carriage of my 3D printer. Just have to undo the 4 screws on the rear of the X carriage here to remove the 3D print head. And attach the rotary handpiece clamp to the end of the X carriage. This opening here allows the chuck key to enter the chuck mechanism and tighten and loosen. So I have this facing forward just to allow easy access. Now that it's attached, let's spin it up just to make sure it works. I'll be installing this bit into the end of the rotary tool. It is a 6mm by 1.5mm diameter cutter, 2 flute upcut with a 3.2mm shank. Just a final check to make sure there's no Z-axis movement. Perfect. And lastly, I'll quickly change over these carbon fibre X-axis rails for 12mm steel rails, as I don't believe the carbon fibre is going to be stiff enough to handle the milling operations that I'll be asking of this 3D printer. And what I normally do is put down a piece of scrap plywood and stick it down onto the heat bed with some double-sided tape on each corner. So this goes down first to protect the aluminium heat surface. And for my actual cutting surface, it'll be this other piece of 6mm plywood. Again with some double-sided tape, but I've used quite a lot of double-sided tape on this side because I'm expecting to cut 4 individual pieces and I'd like all 4 pieces to stay stuck down throughout the entire cut. I don't want any of the individual pieces to come loose while the spinning blade is nearby, as it could pick one up and throw it across the room. I'll just stick this down over the top of the scrap piece beneath it. In Fusion 360 I've quickly drawn up this. This is a 3-pen stand split up into 4 sections, and each section will interlock into the other via these grooves. There are 3 cutouts for 3 pens to slide into, and then 3 grooves for the pens to rest on. The length of each piece is 80mm and the width is 20mm. Each of these interlocking sections is 6mm across to match the 6mm plywood. And to ensure that each interlocking section actually butts up, as I'm using a 1.5mm end mill, I've made sure to go down at least half of that diameter. So this is a semicircle of a 1.5mm circle here, so each part will butt up against each surface. Setting this across to the cam, or the manufacturer as it's called now in Fusion 360, I have 3 milling operations here. The first one is a 2D adaptive. The adaptive is going to mill away approximately 2mm down these 3 circles. The next operation is a 2D contour. This 2D contour is going to cut 3 holes, spiraling down each one. And lastly, the final 2D contour is to mill out each of these 4 pieces, ramping its way down 1mm at a time, moving at 5mm speed. This entire operation will take approximately 35 minutes. To set up our cutting surface, manually home the end of your bit so it's just touching the top of the cutting material, because that will be the Z-axis 0 position, and also the front left of where the cutting is going to start. So I'll start the cutting from about this location here. And just before we begin, don't forget to wear your safety equipment. I'll be wearing hearing protection, eye protection, and respiratory protection. Okay, that just finished. This entire cutting operation took a little over 33 minutes. All the cuts seem to have gone through, and in fact these holes here, one of the cylinders popped out and landed over there. But I will say, this particular handpiece, being all metal, it's quite warm. Like I can hold on to that. But I was worried at the time that this mount that I'd printed out of in just PLA plastic was going to become soft, and then this handpiece potentially become loose. But no, that hasn't occurred. I don't think it got warm enough for the PLA to become soft. Where this particular handpiece was getting warm is where the flexible shaft enters the handpiece. When I first started, you can see I just had the rotary tool just sitting on the table next to it with the flexible shaft coming up. And there's quite a tight bend here. So this part here was getting quite warm. So what I did was, just for the last half, I just ended up holding the shaft, flexible shaft straight. That immediately alleviated a lot of the heat that was building up along here. And also I could hear the handpiece was starting to spin a lot faster once I was doing that as well. So I guess you're just going to be mindful of any friction that builds up with the flexible shaft. But yeah, let me vacuum all this up and we'll dig out our parts. And here are the 4 components of the 3 pen holder milled out of 6mm plywood. And obviously I just spent a few minutes just tidying up the loose ends of these, and they've actually come up quite well. I'll show you this first piece here. You can see where the pens are supposed to rest at the bottom of this pen holder. They've come out very well. You can see the grain along the top is going from left to right, but the grain further down embedded in the plywood, as you can see from the side, is going 90 degrees in the opposite direction. That's what gives plywood its strength. Looking at the next piece, which has the holes milled all the way through, they look quite good as well. And then obviously these 2 last side posts are identical. And I'll also note where I'd left a 1.5mm or a 0.75mm indent for the interlocks. They seem to have come out okay as well on all sides. And just checking the measurements, the width of these pieces are supposed to be 20mm, so let's have a look at this one. So we've come up a bit short there, 19.64. Check this next one, 19.62, 19.7, and 19.68. So they're a bit short of the requested 20mm. And now let's check the length of these pieces. They're supposed to be 80mm each. So let's check this first one. 79.66. 79.58. 79.5. So again, looks like they're all a little bit short from the requested length of 80mm. Pretty close, but not exactly bang on. So 79.6. The next measurement to check are these interlocking sections where all 4 pieces are supposed to slide into each other. So they're supposed to be 6mm. That's what the CAD drawing was. Let's see what they are in real life. 6.2. Let's check this one over here. 6.23. Check this next one. 6.18. This one's, oh no, just didn't have it in there straight. 6.16. So it looks like these interlock pieces are going to be a little bit too loose for the plywood to fit into. It's 6.25, 6.24. So at least they're all the same, but they're all out by the same amount. So I'll need to look at either that one's a bit more actually. Oh no, 6.26. So I'll need to look at either adjusting the calibration in the 3D printer or just adjusting the 3D design if I was going to print this again to allow for the differences between what I've asked for and what the 3D printer is actually milling out of these pieces. So because they're a little bit wider than the width of the plywood, and that was another thing I didn't take into consideration, even though this is actually 6mm plywood, it comes up a little bit short, 5.68. So yeah, as you can imagine, that's going to be swimming when they interlock. Yeah, look at that gap, huge. But saying that, by leaving the half diameter drill on the interlock section, that allows the other interlock section as well to butt up right up against the other piece. Otherwise, if I didn't have the corners drilled out like I have, there'll be the circular corners butting up against each other and they won't quite fit flush. So let's assemble this and see how it goes. And there it is. This triple pen stand or triple pen holder is assembled. Just something quick, I've quickly designed up in CAD. Doesn't quite fit nice and tight, unfortunately, because there's a lot of slack between those interlocks, but looks pretty good. Well, thanks for watching. Hopefully you enjoyed this video. If you did, give it a thumbs up, hit that subscribe button, leave your comments, and I'll catch you next time.